Interactive while loops. We're going to consider this particular form of while loops, the interactive while loops, for three reasons. They've got a special gotcha that you really want to be aware of. Also, we'll develop more general techniques for understanding while loops. And as a practical matter, we've got functions for helping us with input, the utility functions, and we can make some improvements on those, understanding interactive while loops. Let's look at an example. We've already discussed the prompt int function back in the end of the function chapter. The user can choose any int. Often you only want a certain range of integers, like suppose you're looking for an exam score and you know it should be 0 through 100. You could put a prompt out like that, but that doesn't stop the user from entering a number that's out of range. That is clearly wrong, and rather than guessing that it means 100 or something like that, you might want to have them keep trying until they get it right. And here we have an exchange with a possibly rather slow user. They make another mistake the next time, and we're telling them that again that it's out of range. And just to illustrate all the options, suppose they then give you a negative number, that's out of range. And finally, if they enter 100 or any number that's between 0 and 100, then that would be the one you actually want, and you'd finally stop. This is certainly a well-defined idea. Let's make that a function. We're going to prompt for an int in a range. We can have a prompt, like we've had in the previous version of prompt int, but now we're going to have a lower limit and a high limit on the values that we're going to accept. So the call, for instance, for the illustration above might be enter a score 0 through 100 is the prompt, and the limits are, of course, 0 and 100. There's an issue with the common term loop in programming. In English, a loop has no beginning and no end, like a circle. On the other hand, a C# loop has a definite sequence of steps with a beginning and an end, which we may repeat, but it certainly has a beginning and end. Let's look at some pseudocode that would correspond to the sequence up here. We input a number with a prompt, get a response of 233. Print an error message, input a number with a prompt, get 101, print an error message. Input a number, -1, print an error message. Input a number with a prompt, get 100 finally. Then we're ready to return 100. There is clearly a repeating pattern here, but there's a question of where we block it off. Here's one way. Input, print error message. Input, print error message. Input, print error message. Then, well, this last one doesn't fit. Input and return. Here's another way we could do it. Input the number separately, and then we have 3 repetitions of print an error message and input another number with a prompt. That goes on 3 times, and finally we return 100. In choosing what to do here, clearly it's repetitive. We're going to want a loop, but recall, in between different times through the loop, we have the testing of the condition, and also before the first time through the loop. So you want, when you're getting ready for the next time through the loop or the first time through the loop, to have the data you need to test the condition. And since the condition is going to have to do with whether the number is in range, we need a number to test if it's in range. And in this version, at the bottom of the loop, if we get this number, we're going to go back and then test before going through the loop again, and we have the data to test, and so on. Whereas in this previous version, where I've also blocked it off in terms of repeating pattern, it's not a good place to break the pattern. After we print an error message, we don't know whether we're going to need to go through the loop again. We don't know if the next data is good or not. So this is a better model for converting this to C#. We need variables. We're keeping on going to be getting data from the user. If we repeat the loop, we need a name. We can call it number. Next, we need to think about the condition that we're going to have in the while heading. Remember, this is a continuation condition. The easiest thing to think of is that, of course, we want a number that's in the given range, but that's what would make us stop. The continuation condition is if it's not in the range we want. And we've had a condition like that many times where it is out of range if it's smaller than the lower limit, or if it's higher than the high limit. We have a number out of range as long as we have either of those conditions, one or the other. We could go through all the code to put up a prompt, read a line, and all of that to get the data back from the user, but that is totally unnecessary. We would be reinventing the wheel. We still have our general prompt int, and we still want that in there. So we can put in that the first time we set our variable number, where we declare it here, that we get a value via prompt int with the prompt. Now, if the value is not a good one, so that we do go into the loop, as we have here, you can see the steps inside the loop are to print an error message, that's easy, and then it says to input a number. This is one of the gotchas here. It's easy to forget this. We've already put in input a number before the loop, and it's easy to think that we don't need to repeat this, but we definitely do need to repeat it. There are two routes to get to the testing at the beginning of the loop. We've got to have a value before the loop, sequentially in the code, and inside the loop at the bottom of the loop to be ready for the next time through this loop. We also need this data. So a similar idea needs to be twice repeated in the program. Now, the simplest thing you might think to do is just duplicate the line that we had before the beginning of the loop and put the same thing again at the inside at the bottom of the loop. But that's going to give you a problem, because if you copy the whole thing and it was a declaration, you would be redeclaring the variable. So you need to be careful to only take the assignment part, not the declaration here. This would be appropriate to put inside at the bottom of the loop. Let's look at how this comes together. Before we have our condition tested, we need data, so we must prompt the user with the prompt int function that we had in our UIF class. With the prompt, we get our number back, and then we have our loop. If it's a bad number, then we give our error message. We say that the number is out of range. And here again is the thing that was easy to miss. I am repeating, prompting the user, repeating this code because we need it in those two places. Before the loop, we need to then, when we first do this condition, have a value for number. And when we get to the bottom of the loop, in order to be doing something new the next time and not looping forever, we need a new value of number then. When we finally get out of this loop, the only way to exit the loop is if we have a good value for the number. If you check our concrete example that we're following here, when we finally exit the loop, all we've got to do is return the good number. And that's exactly what we put in the code. Let's look at a version of this input in range 1.cs in my examples. So here I've just copied the function that we were talking about. What I want to look at now is the main program where I'm just testing it, calling it, getting a number, and writing it out. The thing I want to point to here is that there's a redundancy. My prompt includes the range that they want for the values as to be a good prompt, but the 0 and the 100, of course, are repeated in the string here, and we also certainly need the numerical data as part of the parameters. We could make a better version if we left out this part and just let the program put it in by looking at these numbers. Let's go back and have a look at that. We can put in code after the prompt to say something like this, where we have what I had in parentheses in the example, plugging in the actual limits here, low lim and high lim. We need this twice, though. Remember, this was an interactive while loop. We have two places we need to prompt. A neater thing to do is what we've got here. We can generate a single string, which we can then use twice. Thus far, we've only used these format strings with substitution in console.write, like here, or console.writeLine, that immediately prints them and is then done. But if we want to instead return the string value for use later, we can use this alternate function, string.format, that does the exact same formatting but has the string returned. So here is a revised example. Here, let's look at the main program. So here I'm just making the prompt be enter a score, and I've got the two other parameters that the limits are 0 and 100. The function then makes a longer prompt by putting together the original prompt and then in parentheses the low limit and the high limit that are the possible values. That longer prompt we are then going to use twice, once before the while loop to set up the value of number for the first test, and then at the bottom inside the loop where we prompt again. For future reference, one caveat on string.format. You recall that we had console.writeLine and console.write. There is no corresponding format line. You have to explicitly put in the new line. Remember, there's a code for it if you want to tell it to have a string with a new line at the end. So let's try this version. So again, let's do something silly. 233, 122, minus 5. All things that are off in either direction. And then finally, let's give me a value that is in range, 95. And we come back. That is the score that we actually keep. The main program has two tests of this. So the second time, it's supposed to be minus 10 through 10, just to show that it isn't assuming 0 and 100 all the time. And what, I can give it minus 15. That's out of range, but if I give it 8, it's in range. Now, I've mentioned the common error here that once you've already said to input the number, forgetting to repeat it at the bottom of the loop. That is eminently possible, and I have a slightly altered version here where I've just commented out that line. This is really bad because with a while loop, we depend on eventually getting a condition that will be false. If we go into this loop, it must be because we had a bad number, like my 233 or something. And so we would go through and print out this error. And if we don't get a new number, this is still 233. So there is no change in the value in the condition. It's still true. We would keep going through the loop and we would never get to change the number or the result of this condition. And we have what is called an infinite loop. On modern computers, you can actually deal with that. The keyboard is set up to recognize Control-C. Let's try this. Well, first of all, I'm going to enter an OK score, which means you never enter the loop, so I'm fine. If I give it, 88, you're cool. But now suppose I enter a number that's not in range. Let's try 15. It's just repeating this over and over. I'm hitting Control character, holding it down, and a C. And you'll notice this is the caret indicates control here. Control C is entered, and that stops the interaction with the keyboard, and the program then finishes, and we're done. I mean, in our case, we could also just kill the window, but stopping it may be better, like that. So remember, holding Control and C. This is in print, the way we're going to see it in this book and other places. It's often written CTRL-C for holding Control and pressing C.